Hi, I'm Steph Chavez. Today we're going to talk about radio frequency, also known as RF PCB design. RF PCB designs refers to the process of designing printed circuit boards that are optimized for RF applications. RF PCBs are used in electronic devices and systems that operate at radio frequencies, ranging from a few megahertz to several gigahertz. These applications include wireless communication devices, radar systems, RF transceivers, and other high-frequency electronic systems. There are several key considerations in RF PCB design. RF signals require proper impedance matching to ensure maximum power is transferred between components. This involves designing transmission lines, such as microstrips and strip lines, with controlled impedance that matches the characteristic impedance of the connected components. Maintaining signal integrity is crucial for RF circuitry. Signal integrity issues, such as reflections and crosstalk, can degrade the performance of the RF system. Careful attention is paid to minimizing signal distortion and maintaining a clean RF signal path. Proper grounding is important in RF PCB design to minimize ground loops and interference. Good grounding practices include the use of a solid ground plane, strategically placed ground vias forming waveguides. Decoupling capacitors are employed to filter out the high-frequency noise and to stabilize the power supply. RF PCBs often involve the use of specialized high-frequency components such as RF connectors, filters, and amplifiers. These components must be carefully selected and placed to minimize the parasitic effects and maintain the RF characteristics. RF traces such as microstrips or coplanar waveguides must be routed with precision in order to avoid signal distortion and maintain the desired impedance. The layout of traces is critical to prevent signal degradation due to losses and interference. Radio frequency devices can generate EMI and be sensitive to EMC issues. RF PCB designers must take measures to reduce emissions and to ensure that the design meets regulatory standards for EMC. Some RF components, especially power amplifiers, can generate heat. Adequate thermal management is crucial to prevent overheating and maintaining the reliability of the RF PCB. RF PCB design requires a good understanding of electromagnetic theory, transmission line theory, and knowledge of the specific requirements of the RF application. Specialized software tools are used to simulate and optimize the RF performance of the design before prototyping and production. Thanks for tuning in. I hope you now have a better understanding of RF PCB design. Keep following for more trends, challenges, and opportunities across the printed circuit engineering industry.